All right, time to start. Now we're on day 3, starting in 5 minutes. I need to actually set this up. I need day 3 here. Create myself a new class. Name this public, and we're implementing this AOC thing, AOC helper. It's gonna complain that we didn't implement these. Probably should have done this a bit earlier, but this is fun. Got plenty of time. Now we want to start with something like this. Parsing is always a bit goofy, kind of depending on what you want. Could take out a lot of the work by just making sure that we parse to something that's easily usable. The tuple thing we did in day 2 was quite a bit goofy, but that worked out. Let's see, we also need a text file here to hold our data input. This is an annoying thing. You can't start typing to help you search properly in this add new item. You have this giant list of things to add, and it kind of just wants you to scroll through it like some sort of maniac. What do we want? Some sort of list. We'll figure out what that list is going to be once we get our inputs. Let's see. Starting in a minute. And we'll just aim for accuracy, I suppose. I don't know how these other super geniuses figure out how to knock these out in a minute. But I guess there's some things you can practice here to get better at these. Sometimes your language choice also helps too. I've seen a lot more functional languages being used here. Ruby, I see a lot. I've seen Scala. And of course, the common stuff, Python, Java. Even a few weirdos who do it in C or some obscure language. Which is fine. It's a good way to learn a new language. Forces you to figure out concepts like, working with lists and parsing things. A lot of basic things that you need to know for a programming language. All right, day 3. What do we got? Oh, it's slow. Oh no. Oh, there we go. We're almost looking at another crash here. Let's see. Trees in this area only grow in exact integer coordinates in a grid. You make up a map, your puzzle input of the input squares. Dots and trees you can see, for example, dots and trees. These aren't your only trees, though, due to something you read about once involving arboreal genetics. The same pattern repeats to the right many times. Okay. So we have a cycle that we have to worry about. You start in the open square to your top left corner and need to reach the bottom below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opt for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3 down 1. From your starting position at the top left, check the position that is right 3 and down 1. Then you check that position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. Locations you checked in the above example are marked here with 0. There's an open space in X where there's a tree. So we got, what, 1, 2, 3, 4, 5, 6, 7 trees. So starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Now it sounds like a bit of geometry work. But yeah, I don't know about that. So let's see, we want, let's go back to our tuple. Is that really what we want? Guess we could do a jagged list instead. Now let's see what we can get out of this. For each line, a list of characters, I guess that works. I mean, it's technically a jagged list. All right, so this needs to be looping. So let's get the length of our so the max number of lines is going to be X, or max number of characters is going to be X length. We'll have to loop through that. What do they want? Following a slope of right 3 and down 1. So What do we want to do? We want to go... We can go down one at a time. Let's see, so we want this to go until we get to the end. Because we're going down one at a time. And we're going to x plus 3. We're going to modulus it to x length. So it'll always loop around. Let's see if input y and then x, is that right? What do we want this to? If it equals hash, oh boy. What are we doing? We're counting trees. We'll run it, see what happens. $69. What are we doing? I only want to solve the last one. I'll throw that in, see if we get the answer. Nope, it's not right. Oh, did we count the first one? We probably did. No, the first one should have been... Oh, I'm not even at the beginning. Yeah, the first one shouldn't have counted. So let's see, we're reading the lines and we're selecting a character array, converting that to a list. So a list of arrays. Yeah, the first one should be Y, and then the second one should be X. And we're going to the right. Right 3, down 1. So we went down 3 and went over 12. And you're saying that's our first one? Down 3, 2, 3. Should be on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That seems right. 1, 2, 3, up, 1, 2, 3, 1, 2, 3. Oh, that doesn't seem right. We should start at 1 and then go down. $289. That's quite a bit bigger. Ooh, right answer. Yeah, it was kind of messed ups like that. I mean, that took me, like 5 minutes or so. Or 10 minutes. It's already 10 minutes in. Anyway. Part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Determine the number of trees you would encounter if, for each of the following slopes, you would start at the top left corner and traverse the map all the way to the bottom. Hmm. 1, 3, 5, 7. Well, let's brute force this. Let's see. Let's create a array. 1, 3, 7. 1, 3, 5, 7. What do you want here? There we go. The array creation always gets me. Let's see, so I guess I could have just done that. I didn't need to create that. All right. So for each of these slopes, we're going to check each one, and you know what? You are editing the solution for 1. Let's get rid of all this. All right, and move this down here. Okay, so for each slope, okay, I guess I can't do that. And instead of having 1 integer for trees, we need a list of trees. So that should cover 1, 3, 5, and 7. And then the last one, write one down too. I'll just do this one more time. We're going to go 2 at a time. We're going to start by going down 2. And we're going to go plus 1. We're going to add this one to our list of trees. And that should cover every slope. And then we'll take trees, how do I do a product? Select many, I think. Let me do this. Product list. Okay, it's not what I wanted. I should have been using longs this whole time, but this is fine. Multiply them all together, and ooh, 0. Are you telling me one of my answers reduced to 0? Let's see, slopes 1, 3, 5, and 7. Write 1 down 1, write 3 down 1. So let's see, this one gave me 84, 71, 77, 88, and this last one, where's the last one? Tree count 35. Oh my gosh. Okay, I screwed up 2 things here. First, I multiplied by 0. And second, I didn't add tree count here. All right, this giant number. Are you correct, giant number? Nope, you certainly are not. So let's see, how did we mess this up? We did slopes 1, 3, 5, and 7. Now, 281 or 289 is what I should have got for answer number 2 here in this list. But what I got instead was 71. Now, why did I get 71? We're looking at slope of 3, so x plus slope modulus x length. It is exactly the same as what we did up here. Oh, you know what? It's because we need to reset x once we're done here. Okay. Let's see. 289. Okay. And the answer we got here. Ooh, an even bigger number. So, even bigger number. You are right. Well, that's the answer. How are we doing on performance? This looks like a mess. 0 milliseconds. I guess it's fast enough. It does look super dumb. Well, I guess I could have made the y length variable too. Did a double for each here. So we iterate through both the x slopes and the y slopes. Yeah, I'm kind of surprised that ran 0 milliseconds. It does seem kind of dumb, but I suppose there's nothing inherently wrong here. How did I do? Let's see. Personal stats. Not good. Yeah, a lot of people figured this out quite a lot faster. Rank is, what? 27, or around 3,000 here. I guess that's what I get. I mean, you gotta be right the first time. You can't be making those mistakes where you have to go back and debug what you're doing. That certainly cost me a lot of time on the first one, and definitely a lot more time on the second one. Well, 10 minutes each, I suppose. Yeah, which is, I don't know. It's good. It seems good to me. 3,000. Now how many people have completed this? Stats? Ooh, almost 80,000 on day 1, 68,000 on day 2. So what is that? It puts me in the top 10% or so. Almost top 5% if I'm 3,000. That's not bad. Alright, that's it for day 2. Looks like it's getting a bit harder. We'll probably be dragging these videos along quite a bit as we go into the next ones. These may turn into multi-hour puzzles. Or not.